Uh, as a math person, I end up resorting to writing an equation, trying to solve it more often than maybe other people would. But you could sit here and do it by trial and error, of course. But if you set up an equation, that's what we're learning to do here, right? Set up an equation and just make one of them the unknown, right? The smaller earthquake's the one that's unknown. I was trying to demonstrate some good form here and use a let statement even, right? That's a good start rather than just having x that we don't know what it is. You're given the ratio. You're given the larger earthquake. So then just solve this equation, and maybe you think that's harder than it is. This is base 10 actually, so it's pretty easy to solve this equation. I will write out that equation, and then I will show you how easy it is to solve, because it's base 10 there. If I take the log base 10 of both sides, what do I get on the right-hand side? Yeah, that just disappears, right? That just disappears, and I get what? I don't even need to put any... Some of you might have done this and put this in front. Log 10. Log 10 just cancels out, right? If it happens to be... You can do that. It'll still work, but log 10 is 1, right? So this is just 7.5 minus x. This is going to be simpler to do. And you got log of 375. However you deal with equations like this, I personally like to, if the x is negative over here, I like to move it to the other side. Makes me more comfortable. I get a little uncomfortable. If the x is on the other side and negative, I like to put it over here. And you don't want to be uncomfortable when you're solving equations, right? You want it to be a nice, comfortable experience. So log of 375 over there, but you can feel free to do it whatever you're happy with, okay? And then you can evaluate that on your calculator, and you are going to get, what are you going to get? 4.926 something. So if we're doing it to one decimal place, we're saying x is roughly 4.9. Here's a way to use some estimation skills to see if you're in the right ballpark here. If it is 375 times as intense, you can use powers of 10 to estimate it and say, what if this said it was 100 times as intense? What would the answer be without doing any of that equation stuff? What would the answer be if it said 100 times as intense? It would be not 7.5, it would be, if this was 100 times more intense than the other one's going to be lower, it would be 5.5. If this was 1,000 times more intense, this would be 4.5. So it's in between those two. It's in between 100 and 1,000 times as intense. So it's got to be between 4.5 and 5.5, which it is. If you get that it is 1.7 or something like that, you know you've done it wrong. The classic wrong thing here is to just subtract the numbers, right? Or even subtract the powers. This is the most common wrong answer here. Like for this one up here, somebody would say 10 to the 8.1 minus 10 to the 6.9, and they'd get something that's totally ridiculous, right? I mean, it doesn't seem ridiculous because maybe you're not familiar with the earthquake scale, but it's you got to divide it, not subtract it. You can subtract the exponents, or you can divide the numbers, but you can't subtract the actual numbers. Okay? If somebody is asking you, if they say you're going to compare the amount of money two people have, you could say how much more money does this person have than this person. Then you subtract the numbers, right? That's a linear scale if you're subtracting the actual numbers. If you say how many times more money does this person have than this person, you don't subtract the numbers, you divide the numbers. Or you could subtract the logarithm, right? It's equivalent. Anyways.